Humans built particle accelerators, split atoms, and still forget where they left their keys. Fact 1. The thermometer. Before thermometers, people diagnosed fever with the ancient medical technique called "you look terrible." Early physicians would touch a forehead, make a dramatic face, and hope for the best. Then came Galileo's thermoscope in the late 16th century, a clever glass device that showed temperature changes but gave no actual numbers. Basically the prototype of "trust me, bro" science. Later, Daniel Fahrenheit arrived and decided water should freeze at 32 and boil at 212, because apparently normal numbers were too mainstream. Celsius looked at this chaos and said, "Absolutely not," creating the cleaner scale most of the world uses today. The thermometer turned illness from guesswork into measurement. It also created the universal parental sentence: "You're not staying home unless that number says so." Science gave us precision, and moms still became stricter than physics. Fact 2. The barometer. Imagine trying to predict weather before the barometer. Farmers basically looked at the sky, listened to their knees, and trusted an uncle named Frank, who claimed he could smell rain. Then in the 17th century, Evangelista Torricelli filled a glass tube with mercury, flipped it upside down, and accidentally terrified everyone nearby. This strange invention measured air pressure and proved the atmosphere actually had weight, which was shocking news for people who thought air was just invisible nothing. Falling pressure meant storms were coming. Rising pressure meant calmer skies. Suddenly, weather prediction became less "my goat is acting strange" and more actual science. The barometer quietly changed navigation, farming, and survival itself. It also gave meteorologists the confidence to still be wrong with much better equipment. Nature remains undefeated, but now at least we can graph our disappointment. Fact 3. The telescope. Before the telescope, humanity looked at the night sky and confidently invented nonsense. People saw random stars and said, "Yes, obviously that cluster is a lion, and that one controls my love life." Then in the early 17th century, Galileo pointed an improved telescope upward and politely ruined everyone's certainty. He saw mountains on the moon, moons around Jupiter, and evidence that Earth was not the center of everything. This was awkward for powerful people who had built entire careers around being confidently incorrect. The telescope transformed astronomy from poetic guessing into observable science. Suddenly, the universe looked bigger, stranger, and far less interested in human drama. It also proved that if you show people clear evidence, they may still get angry anyway. Telescopes taught us the cosmos is vast, beautiful, and apparently full of things that do not care about your horoscope. Fact 4. The compass. Before the compass, long-distance travel was basically professional guessing with better hats. Sailors stared at stars, argued with maps, and occasionally trusted the guy who said, "I've got a feeling it's east." Then, ancient China introduced the magnetic compass, and suddenly a tiny needle became the most reliable employee on the ship. By aligning with Earth's magnetic field, it gave direction even when clouds covered the sky and the coastline disappeared. This changed trade, exploration, and the confidence level of men who absolutely should not have been in charge of boats. European navigation exploded because now people could get lost with scientific accuracy. The compass helped open oceans, connect continents, and accidentally start several historical disasters called colonization. It proved something important. Humanity will always go farther when given direction, especially if there's gold involved and absolutely no plan for the return trip. Fact 5. The steam engine. Before the steam engine, heavy work required horses, water mills, or a deeply unfortunate amount of human suffering. Then Thomas Newcomen and later James Watt turned boiling water into industrial ambition. The steam engine used heated water to create pressure, moving pistons and powering machines with the energy of controlled impatience. Suddenly, factories no longer needed rivers, trains no longer needed horses, and people discovered they could arrive somewhere loudly and covered in coal dust. It launched the Industrial Revolution, which was wonderful for production and terrible for anyone who enjoyed breathing clean air. Cities grew, railroads expanded, and time itself became stricter because trains demanded schedules. The steam engine was humanity saying, "What if pressure but useful?" It changed civilization forever and taught us that most progress begins with someone staring at a kettle far too seriously. Fact 6. The battery. Before batteries, portable electricity was basically a fantasy, and most experiments ended with someone shouting near a lightning rod. Then Alessandro Volta stacked layers of zinc, copper, and salty cloth in 1800, creating the first true battery. It looked less like a scientific breakthrough and more like someone lost an argument with kitchen supplies. But it worked. For the first time, electricity could be stored and used when needed instead of waiting politely for nature to throw a thunderstorm. This changed everything from communication to medicine to the future of every device currently dying at 1%. Batteries made telegraphs possible, powered early experiments, and eventually gave humanity smartphones, which we now use mainly to ignore each other. Volta proved that small stored energy could reshape civilization. He also unknowingly created modern society's deepest fear: forgetting your charger. Fact 7. The radio. Before radio, long-distance communication meant letters, telegraphs, or shouting with unrealistic optimism. Then scientists like James Clerk Maxwell predicted electromagnetic waves, and Guglielmo Marconi turned that theory into something people could actually use without needing a PhD and divine intervention. Radio allowed messages to travel invisibly through the air, which at first sounded suspiciously like witchcraft with paperwork. Ships at sea could call for help, news traveled faster, and families gathered around wooden boxes to hear voices from cities they had never seen. It changed war, entertainment, and the terrifying rise of advertisements for products nobody needed. Radio made the world feel smaller and louder at the same time. It proved humans would use incredible scientific breakthroughs for education, emergency rescue, and eventually arguing about baseball scores with complete emotional commitment. Fact 8. The light bulb. Before the light bulb, nights belonged to candles, oil lamps, and the constant possibility of accidentally setting your curtains on fire while reading. Then inventors like Humphrey Davy, Joseph Swan, and famously Thomas Edison made electric light practical enough for ordinary homes. Edison did not invent light itself, despite what some school textbooks behave like, but he helped make it reliable, affordable, and harder to explode indoors. The bulb used electricity to heat a filament until it glowed, which is basically controlled burning with better public relations. Suddenly, people could work, read, and regret life decisions long after sunset. Cities became brighter, factories stayed open later, and sleep quietly filed a complaint. The light bulb extended productivity and modern life itself. It also introduced humanity's favorite late-night tradition, standing in the kitchen at 2 a.m., questioning everything. Fact 9. The X-ray machine. Before X-rays, diagnosing a broken bone involved touching the injury, watching the patient scream, and concluding, "Yes, that seems bad." Then Wilhelm Conrad Röntgen discovered X-rays in 1895 while experimenting with cathode rays and accidentally creating one of medicine's greatest breakthroughs. He noticed invisible rays could pass through soft tissue but not bone, meaning doctors could finally see inside the body without opening it like a badly wrapped gift. The first X-ray image was his wife's hand, and she reportedly looked at it and said she had seen her own death, which honestly feels fair. X-ray machines transformed medicine, surgery, and emergency care forever. They also gave airports a way to judge your luggage choices. Physics turned invisible radiation into life-saving clarity, proving science is often just curiosity with surprisingly alarming side effects. Fact 10. The refrigerator. Before refrigerators, keeping food fresh meant salt, ice blocks, and praying your milk survived the afternoon. Summer was less a season and more a countdown to disappointment. Then refrigeration changed everything by using compression, evaporation, and the magical feeling of opening the fridge at midnight for no reason. Early inventors like William Cullen explored artificial cooling, but practical household refrigerators arrived much later and quickly became the quiet kings of the kitchen. Suddenly, food lasted longer, cities could grow bigger, and people stopped treating leftovers like a dangerous gamble. Ice boxes retired, food safety improved, and the phrase "smells fine to me" became slightly less necessary. Refrigerators are basically physics disguised as a white box humming in the corner. They preserve groceries, midnight regrets, and that one container everyone fears opening because nobody remembers what civilization it came from. Fact 11. The airplane. Before airplanes, crossing oceans meant ships, patience, and enough luggage to survive emotional transformation. Then the Wright brothers looked at birds and decided with extraordinary confidence, we can probably do that. In 1903, their powered aircraft flew for 12 seconds, which sounds unimpressive until you remember humanity had spent all of history not doing that at all. The airplane used lift, thrust, drag, and the refusal to accept gravity's opinion. Suddenly, continents felt smaller, wars became faster, and family vacations became arguments at 30,000 feet. Aviation transformed trade, science, and the universal experience of clapping when the landing was slightly too dramatic. Planes proved humans would absolutely challenge the sky itself if it meant arriving somewhere sooner. They also introduced airport security, which remains physics mixed with emotional damage and overpriced sandwiches. Fact 12. The microwave oven. Before microwave ovens, reheating leftovers required a stove, patience, and accepting that soup would somehow be cold and boiling at the same time. Then Percy Spencer noticed a chocolate bar melting near radar equipment and responded like a true scientist by immediately experimenting with food. In 1945, this accidental discovery led to the microwave oven, which uses electromagnetic waves to excite water molecules and heat food from the inside. It sounded futuristic because it basically was. Suddenly, dinner could happen in 3 minutes, and every office break room gained the permanent smell of someone's fish mistake. Microwaves changed kitchens, schedules, and the confidence of people who now believed cooking meant pressing one button. It proved science could save time, though not enough to stop everyone from staring impatiently through the little glass window like it was live theater. Fact 13. The seismograph. Before seismographs, earthquakes were measured using the highly technical system of "did your furniture survive?" People guessed strength based on panic levels and how dramatically the dishes fell. Then came the seismograph, first imagined in ancient China by Zhang Heng, and later refined into the modern instrument that records Earth's tantrums with scientific elegance. It detects ground motion using suspended masses that stay relatively still while the Earth moves beneath them, which is surprisingly similar to how most people react to Monday mornings. Seismographs allowed scientists to study earthquakes, locate epicenters, and understand the restless mood swings of our planet. They turned disaster into data and fear into preparation. Of course, they also confirmed something unsettling. The ground beneath us is not nearly as committed to stability as we would like. Earth apparently also enjoys dramatic entrances. Fact 14. The laser. Before lasers, people heard the word and imagined either science fiction villains or cats having the best afternoon of their lives. But lasers are one of the most precise inventions in modern physics. The word itself stands for light amplification by stimulated emission of radiation, which sounds like a government program nobody understands. First demonstrated in 1960 by Theodore Maiman, lasers produce focused, coherent light, powerful enough for surgery, communication, manufacturing, and making presentations slightly more aggressive. They read barcodes, carry internet signals, and fix eyesight while quietly pretending not to be magic. A laser is basically light that got organized and developed ambition. It transformed medicine, industry, and every professor who enjoys pointing at slides with unnecessary authority. Science took ordinary light and said, "What if this had discipline?" And the universe reluctantly agreed. Fact 15. The satellite. Before satellites, global communication depended on cables, towers, and hoping the message survived human interpretation. Then humanity launched machines into orbit and decided space should also have office equipment. The first artificial satellite, Sputnik, went up in 1957 and made the entire world collectively nervous, especially because it was basically a metal ball beeping with confidence. Satellites use orbital physics to circle Earth while handling communication, weather forecasting, navigation, and the deeply important task of helping you find the nearest coffee shop. They transformed television, military strategy, and our ability to complain about traffic using GPS with perfect certainty. Satellites prove that sometimes the best place to solve Earth's problems is slightly above it. They also created the strange reality where your phone can locate you faster than most of your friends can remember your birthday. Fact 16. The MRI scanner. Before MRI scanners, doctors often had to choose between educated guessing and surgery that began with, "Let's take a look inside." Then magnetic resonance imaging arrived and gave medicine something revolutionary: detailed pictures without turning patients into unfortunate science projects. MRI uses strong magnetic fields and radio waves to map the body's soft tissues, making it possible to see the brain, muscles, and organs with remarkable precision. It is incredibly useful and also feels like being placed inside an expensive drum solo. Patients lie perfectly still while the machine produces sound suggesting a robot is building furniture nearby. MRI changed diagnosis, treatment, and the phrase, "We caught it early." It proved physics could become deeply personal. Also, it taught everyone the same lesson: if they ask whether you have metal inside you, answer honestly and immediately. Fact 17. The elevator. Before elevators, living on the top floor meant either being wealthy enough for servants or unlucky enough to carry groceries like a medieval punishment. Stairs were society's way of asking, "How badly do you want this apartment?" Then Elisha Otis introduced the safety elevator in the 19th century and changed cities forever. His brilliant idea was not just lifting people upward, but making sure they did not return to Earth at motivational speaker speed if a cable snapped. He famously demonstrated this by standing on a platform and cutting the rope in front of a horrified crowd. The safety brake worked, and suddenly buildings could grow taller without becoming vertical fitness programs. Elevators transformed architecture, business, and human laziness into a respectable engineering goal. They also created the universal awkward silence of strangers avoiding eye contact for 12 floors while pretending buttons are fascinating. Fact 18. The washing machine. Before washing machines, laundry was less a chore and more a full-contact sport involving soap, buckets, and emotional exhaustion. Washing clothes meant scrubbing fabric by hand, boiling water, and questioning every life choice that led to owning white shirts. Then mechanical washing machines arrived and quietly became one of civilization's greatest peace treaties. By using rotating drums, water, and controlled motion, they replaced hours of labor with the modern ritual of forgetting clothes inside for 2 days. Early versions were hand-powered, which still felt rude, but electric models changed everything. They saved time, improved hygiene, and gave humanity the confidence to buy far too many socks. The washing machine proved that physics could dramatically improve domestic life without needing applause. It also created one of adulthood's greatest mysteries: where exactly all the missing single socks are being sent. Fact 19. The vacuum cleaner. Before vacuum cleaners, cleaning carpets meant beating them outside like they had personally offended your family. Dust removal was loud, dramatic, and suspiciously close to anger management. Then inventors like Hubert Cecil Booth realized maybe there was a better strategy than attacking furniture in public. The vacuum cleaner used suction to pull dirt away, which sounds obvious now, but once felt like science fiction for people emotionally attached to brooms. Early machines were enormous and sometimes horse-drawn, because apparently every great invention begins by being wildly inconvenient. Modern vacuums became smaller, faster, and somehow still terrifying to every household pet. They transformed hygiene, allergies, and the illusion that cleaning for 15 minutes means your life is under control. Vacuums proved invisible dirt could still ruin your peace, and that one machine could sound like judgment rolling across the living room. Fact 20. The camera. Before cameras, if you wanted to remember someone's face, your options were memory or paying an artist who might accidentally make you look richer than reality. Portraits were expensive, slow, and suspiciously flattering. Then photography arrived and turned light itself into a witness. Early pioneers like Joseph Nicephore Niepce and Louis Daguerre discovered ways to capture images permanently, proving sunlight could also have paperwork. Suddenly, moments could be preserved exactly as they were, including awkward expressions history had previously allowed people to deny. Cameras changed journalism, science, art, and family vacations, where at least one person is always blinking. They gave evidence, memories, and eventually the invention of taking 200 photos of lunch for no clear reason. The camera proved time could be paused, and humanity immediately used that power for both moon landings and very aggressive vacation slideshows. Fact 21. The radar system. Before radar, detecting danger in fog or darkness often relied on optimism and someone squinting heroically into the distance. Ships and planes basically hoped bad things would announce themselves politely. Then radar arrived and gave humans the ability to see with radio waves, which sounds like a superhero skill but came with much more paperwork. By sending out electromagnetic waves and measuring their reflection, radar could detect objects far away, even when visibility was terrible. It became essential during World War II, turning defense from panic into preparation. Pilots, sailors, and meteorologists suddenly had a better relationship with surprise. Radar changed transportation, warfare, and weather forecasting, though somehow storms still arrive exactly when you forget an umbrella. It proved invisible waves could protect lives, and also that technology can be incredibly advanced while still not helping anyone find decent parking. Fact 22. The CT scanner. Before CT scanners, doctors often had X-rays and a professional expression that meant, well, that is concerning. Seeing inside the body was possible, but detail was limited, and sometimes medicine felt like solving a puzzle with missing pieces. Then computed tomography arrived and gave hospitals the ability to create cross-sectional images of the human body like a very expensive loaf of bread. Using rotating X-rays and computer processing, CT scanners reveal organs, bones, and internal problems with remarkable clarity. It changed emergency care, cancer detection, and the speed at which doctors could say, "Good thing we checked." Patients lie still inside a machine that looks calm, but charges like it knows your insurance personally. CT scans proved physics and computing together could save lives while also teaching everyone to suddenly remember every bad decision before test results. Fact 23. The solar panel. Before solar panels, sunlight mostly helped with tanning, farming, and dramatic movie scenes about self-discovery. Then scientists realized that the giant nuclear fireball in the sky might also be useful for electricity. Solar panels use photovoltaic cells to convert sunlight directly into power, which is honestly the most polite form of stealing from the universe. First developed seriously in the 20th century, they turned rooftops into quiet power stations and gave homeowners a new personality trait. Solar energy changed satellites, remote science stations, and long arguments about electricity bills at family dinners. It offered cleaner energy and the deeply satisfying feeling of your house doing something productive while you are not. Solar panels proved the sun could be billed for its services, though sadly it still refuses customer support and continues rising without consulting anyone. Fact 24. The particle accelerator. Before particle accelerators, understanding atoms meant a lot of theory, chalkboards, and scientists confidently saying, "We're pretty sure something tiny is happening." Then particle accelerators arrived and physics decided subtlety was overrated. These machines use electric fields to speed particles close to the speed of light and smash them together because apparently the best way to understand reality is by breaking it very carefully. Devices like the Large Hadron Collider helped confirm particles such as the Higgs boson, proving the universe runs on rules far stranger than most people's taxes. Accelerators changed medicine too, helping create cancer treatments and imaging technology. They are massive, expensive, and suspiciously similar to humanity, building the world's most advanced excuse to hit things. Particle accelerators prove that if you ask small enough questions, the answers require a machine larger than a subway system. Fact 25. The clock. Before accurate clocks, time was mostly a suggestion. People looked at the sun, listened for church bells, and accepted that "I'll be there soon" could legally mean next Thursday. Then mechanical clocks arrived and civilization became dramatically less relaxed. By using gears, pendulums, and the human obsession with control, clocks turned time into something measurable instead of philosophical. Galileo studied pendulums, Christian Huygens improved precision, and suddenly trains, factories, and school teachers gained dangerous new power. Accurate clocks made navigation safer, business stricter, and excuses much weaker. You could no longer blame lateness on vague cosmic uncertainty when a giant tower downtown was literally judging you every hour. The clock changed science and society by proving time could be divided, tracked, and weaponized. It also created alarms, humanity's daily reminder that physics can absolutely ruin a perfectly good dream. Fact 26. The pendulum. Before the pendulum became useful science, it was mostly something hanging in old houses making people nervous at night. Then Galileo noticed a swinging lamp in a cathedral and did what scientists do best: stared at it long enough to accidentally change history. He realized the pendulum's swing remained surprisingly regular, which made it perfect for measuring time. This simple motion became the heart of accurate clocks and transformed astronomy, navigation, and every student forced to explain periodic motion in class. Pendulums proved that gravity could be predictable, which was comforting because most of life clearly was not. They also helped demonstrate Earth's rotation through the famous Foucault pendulum, politely informing humanity that yes, the planet is moving, and no, your opinion does not matter. Sometimes science advances because someone gets distracted by a lamp and refuses to move on. Fact 27. The prism. Before prisms, people looked at sunlight and thought white light was just white light. End of story, no further questions. Then Isaac Newton passed sunlight through a glass prism and politely informed everyone that sunlight was basically hiding a rainbow the entire time. The prism bends light because different wavelengths travel differently through glass, separating colors into the visible spectrum. It was less an experiment and more sunlight being exposed for lying about its identity. This changed optics, astronomy, and our understanding of light itself. Suddenly, color was not magic, divine mood swings, or whatever people had been confidently saying before. Prisms helped lead to spectroscopy, allowing scientists to study stars without physically visiting them, which saved a lot on travel expenses. The prism proved that even ordinary sunlight contains secrets, and apparently so does every school science fair project. Fact 28. The electric generator. Before electric generators, getting electricity meant either static shocks from carpets or hoping lightning had good timing. Reliable power was not exactly a household feature. Then Michael Faraday discovered electromagnetic induction and changed modern life forever. By moving a conductor through a magnetic field, electricity could be generated continuously, which sounds simple now, but once felt like stealing power directly from the laws of nature. Generators became the beating heart of power stations, factories, and every building where someone says, "Why is the Wi-Fi down?" They turned motion into energy and made large-scale electricity practical for civilization. Without generators, modern cities would mostly be candles and regret. They proved that magnets were not just refrigerator decorations, but deeply serious business. Humanity basically spun metal near magnets and accidentally created the entire modern economy with slightly louder machines. Fact 29. The transformer. Before electrical transformers, sending electricity over long distances was like trying to deliver soup with a fork. Technically possible, but mostly disappointing. Power would be lost, cities stayed limited, and engineers developed stress wrinkles early. Then transformers arrived and quietly became the reason modern power grids do not collapse from embarrassment. Using electromagnetic induction, transformers increase or decrease voltage efficiently, allowing electricity to travel far and safely enter your toaster without becoming a small apocalypse. Nikola Tesla and George Westinghouse helped make alternating current practical, while Thomas Edison watched this with the emotional stability of a man losing an argument publicly. Transformers changed industry, homes, and every dramatic storm outage where someone says, the whole neighborhood is dark. They proved invisible energy needs careful management, and that some of the most important inventions are the ones nobody notices until absolutely everything stops working. Fact 30. The spectroscope. Before spectroscopes, studying stars was mostly elegant guessing from very far away. Astronomers looked upward and said things like, "That one seems hot and emotionally distant," which, to be fair, was accurate but not especially scientific. Then the spectroscope arrived and turned starlight into evidence. By splitting light into its component wavelengths, it revealed unique spectral lines showing what elements were present. Suddenly, scientists could identify hydrogen, helium, and other elements in stars without needing a ladder tall enough to be concerning. This changed astronomy, chemistry, and humanity's confidence in asking questions about things absurdly far away. Spectroscopy proved the universe leaves fingerprints everywhere if you know how to look. It also taught us that stars are basically giant chemical reports with excellent lighting. Science once again replaced mythology with graphs, which is somehow less poetic but significantly more useful. Fact 31. The gyroscope. Before gyroscopes, keeping direction during motion was surprisingly difficult, especially when ships, planes, and people all insisted on moving at the worst possible moments. Then the gyroscope arrived and said, very calmly, "I will handle this." A spinning wheel resists changes to its orientation because angular momentum is basically physics refusing to be interrupted. This made gyroscopes perfect for navigation, stabilization, and convincing pilots they were not upside down during terrible weather. They became essential in aircraft, submarines, spacecraft, and eventually the phone in your pocket that somehow knows when you turned it sideways to watch videos you absolutely should not be watching at work. Gyroscopes proved spinning things can create stability, which feels emotionally inspiring if not slightly suspicious. They turned rotation into trust and quietly helped humanity stop getting lost, quite so professionally. Fact 32. The magnet. Before magnets became serious science, they were basically mysterious rocks making iron behave suspiciously. People probably found lodestones and assumed the Earth was either magical or deeply sarcastic. Then physics stepped in and explained magnetism through invisible fields, which honestly did not make it sound less magical. Magnets create forces that attract or repel certain materials, and this simple principle powers far more of life than most people realize. They guide compasses, run electric motors, store data, and hold your questionable vacation photos to the refrigerator like tiny judgmental assistants. Without magnets, generators, speakers, and modern technology would collapse into very expensive silence. They proved invisible forces can shape civilization while asking for absolutely no applause. Also, they created the childhood experience of trying to push two like poles together and learning that sometimes physics simply says no with remarkable confidence. Fact 33. The electric motor. Before electric motors, machines relied on steam, muscles, or the timeless strategy of find a stronger horse. Then electric motors arrived and quietly made modern civilization much less sweaty. Using magnetic fields and electric current, motors convert electrical energy into motion, which sounds simple until you realize that motion includes elevators, fans, trains, washing machines, and the tiny dramatic spin inside your toothbrush. Michael Faraday laid the groundwork, and engineers everywhere immediately decided spinning things should now happen automatically. Motors transformed factories, transportation, and domestic life by making work faster and humans lazier in the best possible way. They are the reason your blender can sound like it is preparing for takeoff. Electric motors prove that invisible energy could become useful movement, and that once humanity automates one task, it immediately begins searching for 12 more it never wants to do again. Fact 34. The wind turbine. Before wind turbines, wind was mostly appreciated for sailing ships, ruining hairstyles, and aggressively closing car doors at the worst moment. Then humans looked at moving air and decided it should start paying rent. Wind turbines use blades turned by wind to spin a generator and produce electricity, which is basically convincing the atmosphere to do chores. Windmills existed for centuries grinding grain and pumping water, but modern turbines turned breezes into serious power infrastructure. They changed renewable energy, rural landscapes, and the number of heated family arguments about whether they look elegant or like giant fans with ambition. Wind power proved that clean energy could come from something free, invisible, and impossible to argue with directly. It also created the strange sight of enormous machines quietly harvesting weather, while nearby people still forget to charge their phones. Fact 35. The submarine. Before submarines, exploring underwater mostly involved holding your breath and making very optimistic life choices. The ocean remained a mysterious place full of pressure, darkness, and creatures that looked like they were designed during a stressful meeting. Then submarines arrived and gave humans the confidence to bring metal tubes into places clearly marked by nature as "Please do not enter." By controlling buoyancy with ballast tanks, submarines can dive, rise, and move beneath the surface with remarkable precision. They changed warfare, oceanography, and our understanding of the deep sea. Scientists could study underwater ecosystems, while militaries discovered new and creative ways to make everyone nervous. Submarines proved humans will absolutely go anywhere if engineering makes it technically possible. They also taught us that hearing an unexplained sound underwater is somehow terrifying even when you fully paid for the experience. Fact 36. The sonar system. Before sonar, finding objects underwater involved ropes, luck, and the emotional resilience to admit you had probably lost the ship. The ocean is excellent at hiding things and not returning calls. Then sonar arrived and gave humans the ability to locate objects using sound waves, which feels like teaching water to answer questions. By sending sound pulses and measuring their echoes, sonar detects depth, submarines, fish, and occasionally the reason your captain suddenly looks concerned. It became essential for navigation, marine science, and wartime strategy, proving once again that invisible waves run most of civilization while we argue about passwords. Sonar transformed ocean exploration and helped map places humans could not easily reach. It also created the cinematic moment where everyone on a submarine stares silently at one beep, and suddenly the music gets very expensive. Fact 37. The Geiger counter. Before Geiger counters, radiation was the kind of invisible problem people discovered mainly by regretting everything later. You could not smell it, see it, or politely ask it to leave. Then Hans Geiger helped create the Geiger counter, a device that detects ionizing radiation and makes danger audible through those famous clicking sounds that instantly improve nobody's mood. It works by measuring particles passing through a gas-filled tube, turning invisible hazards into information and mild panic. Geiger counters changed nuclear science, medicine, and safety by giving humans a way to know when the room itself was being rude. They became symbols of both scientific progress and cinematic doom. The Geiger counter proved that sometimes the most important inventions are the ones that tell you to slowly back away and reconsider every career decision you have ever made. Fact 38. The jet engine. Before jet engines, air travel was slower, louder in the wrong ways, and somehow still stressful enough to inspire poetry about trains. Then jet propulsion arrived and decided flying should feel like controlled explosions with excellent customer service. Frank Whittle and Hans von Ohain helped develop practical jet engines by using compressed air, fuel combustion, and thrust powerful enough to make gravity reconsider its authority. Jets transformed aviation, shrinking the world and making breakfast in one country and dinner in another a normal inconvenience. They changed commerce, military strategy, and the emotional relationship between humans and turbulence. Jet engines proved that moving extremely fast through the sky could become routine, even if passengers still clap after suspicious landings. They also created airports where time stops, coffee becomes expensive, and everyone suddenly becomes an expert on suitcase geometry. Fact 39. The hovercraft. Before hovercraft, transportation politely accepted that land and water were different things with separate rules and paperwork. Then someone looked at both and said, "What if we respected neither?" The hovercraft uses a cushion of high-pressure air beneath it, allowing the vehicle to glide over water, mud, ice, and flat land like physics briefly forgot to object. Developed seriously in the 20th century by Christopher Cockerell, it became useful for rescue missions, military transport, and making ordinary boats feel emotionally outdated. Hovercraft proved friction is less a law and more a negotiation if you bring enough engineering. They are fast, loud, and somehow always look like they were invented by someone who lost patience with roads entirely. It is transportation designed by a person who saw boundaries and responded with pure aerodynamic disrespect. Fact 40. The Space Telescope. Before space telescopes, astronomers studied the universe through Earth's atmosphere, which is like trying to watch a masterpiece through a foggy bathroom mirror. Air bends light, weather interrupts, and the planet itself behaves like an unhelpful coworker. Then space telescopes like Hubble escaped all that drama and gave humanity a clearer view of the cosmos. By orbiting above the atmosphere, they capture sharper images of galaxies, nebulae, and stars so distant, their light started traveling before humans invented chairs. Space telescopes changed astronomy by revealing black holes, measuring cosmic expansion, and reminding us how hilariously small our daily problems are. They prove the universe is far stranger and more beautiful than expected. They also gave scientists the professional privilege of saying, "We found something impossible," which is basically astronomy's version of winning the lottery. Fact 41. The GPS system. Before GPS, finding your way meant paper maps, wrong turns, and the ancient ritual of pretending you definitely knew where you were going. People unfolded giant maps in cars like they were preparing for surgery. Then the global positioning system arrived and gave satellites the deeply personal job of judging your navigation skills. GPS uses signals from orbiting satellites and timing precise enough to make your wristwatch feel unemployed. It calculates your location anywhere on Earth, which is incredibly useful and slightly unsettling. It changed travel, shipping, rescue operations, and humanity's ability to confidently ignore directions from passengers. Suddenly, recalculating became the calm, robotic voice of your own bad decisions. GPS proved that space technology could help you find a coffee shop 3 blocks away. It also taught us that even with perfect guidance, people will still somehow miss the obvious exit. Fact 42. The 3D printer. Before 3D printers, creating an object meant factories, tools, and at least one person saying, "That will take 3 weeks." Then 3D printing arrived and let people manufacture things by essentially convincing a machine to do very patient frosting work with plastic, metal, or resin. Layer by layer, it builds objects from digital designs, turning imagination into something you can immediately drop on the floor. It changed engineering, medicine, and education by making prototypes faster and cheaper. Scientists print prosthetics, engineers test designs, and someone somewhere is absolutely printing another tiny dragon for no urgent reason. It proved manufacturing could become personal, local, and strangely addictive. The 3D printer is basically physics meeting stubborn creativity and saying, "Fine, make your weird little object." Civilization advanced, and so did the number of plastic dinosaurs on office desks. Fact 43. The drone. Before drones, getting an aerial view required helicopters, ladders with unrealistic confidence, or standing on a chair and making poor life decisions. Then drones arrived and gave cameras the freedom to quietly hover above your barbecue like judgment with propellers. Using gyroscopes, sensors, motors, and remote control systems, drones maintained stable flight with surprising precision. They changed photography, farming, rescue missions, and military strategy, proving once again that humans will automate anything if it looks cool enough. Farmers inspect crops, filmmakers capture dramatic sunsets, and neighbors become suspicious of anyone who says, "I'm just testing something." Drones made the sky feel smaller and slightly nosier. They proved flight no longer required a pilot inside the machine, only a person nearby saying, "Wait, I think I lost signal." Modern physics has never looked so accidentally threatening to backyard privacy. Fact 44. The superconductor. Before superconductors, electricity traveling through wires always lost some energy as heat, like a delivery service that charges extra for disappointment. Then scientists discovered materials that, under very low temperatures, allow electricity to flow with zero resistance. This sounded less like physics and more like a suspiciously generous loophole in reality. Superconductors make powerful MRI machines, maglev trains, and advanced scientific instruments possible. They prove that sometimes the universe says, fine, but only if you make it incredibly cold first. These materials can create magnetic levitation, which means trains can literally float while commuters still somehow complain about delays. Superconductors changed energy research and high-speed transport by showing efficiency on an almost unfair level. They also taught scientists that some of the greatest breakthroughs begin with freezing things until they behave properly, which honestly works for more than just physics. Fact 45. The maglev train. Before maglev trains, rail travel involved wheels, tracks, and the familiar soundtrack of metal complaining about friction. Then engineers decided friction itself was rude and built trains that float. Magnetic levitation trains use powerful magnets to lift and propel the train above the track, removing direct contact and allowing extraordinary speed with less wear. It looks less like transportation and more like the future arriving early and slightly showing off. Maglev systems changed high-speed travel by proving trains did not need wheels to be dramatically faster than your patience. They are smoother, quieter, and far more impressive than explaining your delayed regular commuter train. Physics turned repelling magnetic fields into practical motion and gave humanity another reason to be late with better excuses. It proved that if you let science handle transportation, even gravity starts feeling like optional paperwork. Fact 46. The nuclear reactor. Before nuclear reactors, large-scale energy mostly came from burning things and hoping the smoke looked responsible enough. Then humanity learned that atoms themselves contained ridiculous amounts of energy and immediately responded with both brilliance and several very concerning meetings. Nuclear reactors use controlled fission, splitting atomic nuclei to release heat, which then produces steam and electricity. It is basically boiling water with the power source of existential philosophy. Reactors changed global energy, medicine, and politics by offering enormous power with equally enormous consequences if someone says, "I'm sure this is fine." They proved that tiny particles could power entire cities, which is both inspiring and slightly terrifying. Nuclear energy taught us that science does not care whether humans are emotionally ready. It simply hands over the blueprint and watches to see whether we build progress or headlines. Fact 47. The quantum computer. Before quantum computers, normal computers handled problems by following clear yes or no logic, like extremely fast librarians with trust issues. Then quantum physics arrived and said, what if the answer was yes, no, and emotionally complicated at the same time? Quantum computers use qubits, which can exist in multiple states simultaneously through superposition plus entanglement, which sounds like either advanced science or a very dramatic relationship status. They promise breakthroughs in chemistry, cryptography, and solving problems too massive for classical machines. This is not your laptop becoming slightly smugger. It is an entirely different way of thinking about computation. Quantum computers prove reality itself is stranger than most conspiracy theories. They also remind everyone that the smartest people on Earth regularly explain their work using phrases that sound like they were invented during a fever dream in a mathematics department. Fact 48. The James Webb Space Telescope. Before the James Webb Space Telescope, humanity had already seen deep space, but mostly like someone trying to admire ancient art through a dirty window. Then Webb arrived and politely shattered expectations. Launched to observe infrared light, it can look farther back in time than previous telescopes, capturing galaxies formed near the beginning of the universe itself. Its giant gold mirrors are not there for style, though they do look like physics won an award ceremony. Webb studies exoplanets, star formation, and the earliest cosmic history, asking questions so large they make taxes feel refreshingly simple. It proved our greatest discoveries often begin by looking farther, not louder. Humanity built a machine 1,000,000 miles away just to ask where everything started. And somehow, after all that brilliance, we still forget why we walked into the kitchen. Fact 49. The Hubble Space Telescope. Before Hubble, astronomers were basically trying to admire the universe through Earth's atmosphere, which behaves like a greasy fingerprint on the lens of existence. Stars blurred, distant galaxies looked like suspicious smudges, and everyone politely pretended this was acceptable. Then the Hubble Space Telescope launched in 1990 and changed cosmic photography forever. Orbiting above the atmosphere, it captured images so sharp they made humanity collectively pause and say, "Oh, so we are absolutely tiny." Hubble helped measure the age of the universe, confirmed the existence of supermassive black holes, and showed galaxies colliding like celestial traffic accidents. It turned astronomy into front-page wonder instead of dusty textbook diagrams. It also famously launched with a flawed mirror, proving even billion-dollar science projects can begin with the energy of assembling furniture incorrectly. Thankfully, astronauts fixed it, and Hubble became the universe's most expensive pair of glasses. Fact 50. The electron microscope. Before electron microscopes, scientists looked at tiny things through regular microscopes and eventually reached the frustrating limit of, well, it's still just a blur. Light could only do so much before physics crossed its arms and refused further cooperation. Then the electron microscope arrived and decided if light was too weak, maybe we should use electrons instead, like perfectly reasonable people. By using electron beams with much shorter wavelengths, it revealed structures thousands of times smaller than ordinary microscopes could show. Suddenly, viruses, cell structures, and materials, science became far less mysterious and far more unsettling. Researchers could see details so small they made dust look like architecture. It changed biology, medicine, and nanotechnology by proving there is always another smaller level of reality waiting to judge your understanding. Science once again responded to limitations by building something that sounded slightly like villain equipment. Fact 51. The pacemaker. Before pacemakers, an irregular heartbeat was often treated with concern, optimism, and a deeply unhelpful suggestion to just rest. If your heart decided to improvise its rhythm, medicine had limited options and a lot of serious facial expressions. Then the pacemaker arrived and gave the human body its own tiny backstage manager. This device sends electrical impulses to regulate heartbeats, keeping rhythm where biology had started experimenting too creatively. Early pacemakers were bulky enough to look like someone strapped a radio to your chest, but modern versions are small, precise, and life-changing. They transformed cardiology by proving electricity could directly support life itself. It is one of the most personal uses of physics, not powering cities, but keeping one person's tomorrow on schedule. The pacemaker taught humanity that sometimes survival depends on admitting your heart needs a little professional supervision. Fact 52. The defibrillator. Before defibrillators, cardiac arrest was often a terrifying moment, followed by everyone hoping panic might somehow count as medical intervention. Then defibrillators arrived and introduced the bold scientific concept of helping the heart by aggressively interrupting it. A defibrillator delivers an electric shock to restore a normal heartbeat when the rhythm becomes dangerously chaotic. Contrary to movie logic, it does not restart a heart that has fully stopped like a magical lightning slap. It resets dangerous electrical patterns, which is far less cinematic but much more useful. This invention changed emergency medicine, hospitals, and every dramatic television scene involving someone yelling "clear" with suspicious confidence. It proved that controlled electricity could save lives, not just power your toaster and ruin your hair with static. Defibrillators are basically physics saying, "Everyone calm down, I'm handling the panic professionally from here." Fact 53. The insulin pump. Before insulin pumps, managing diabetes often meant strict schedules, repeated injections, and living with the emotional tension of carrying both medical discipline and emergency snacks everywhere. Then insulin pumps arrived and turned treatment into something smarter and far more precise. These small devices deliver insulin continuously, mimicking the body's natural rhythm better than occasional injections alone. They use sensors, careful programming, and the kind of reliability people wish their alarm clocks had. It changed medicine by making blood sugar control safer, more flexible, and less like negotiating with biology every hour. Modern pumps can even communicate with glucose monitors, creating a tiny private conversation inside your body about survival logistics. It proved physics and engineering could quietly improve daily life without dramatic headlines. Also, it reminded everyone that sometimes the most advanced technology is simply helping someone eat lunch like a normal person. Fact 54. The fusion reactor. Before fusion reactors, humanity looked at the sun and thought, that seems useful and probably impossible to copy indoors. Nuclear fission already gave us enormous energy by splitting atoms, but fusion promised something even bigger. Joining atoms together like stars do, with less long-term waste and significantly more scientific headaches. Fusion reactors attempt to force hydrogen nuclei together at temperatures so absurd they make lava look like a polite warm beverage. Magnetic confinement systems like tokamaks try to hold plasma hotter than the sun, without the building taking that personally. It is basically humanity attempting to bottle a star and asking it to behave responsibly. Fusion has not fully powered cities yet, but every breakthrough moves us closer. It proves science is sometimes just decades of brilliant people saying, "This should work," while the universe replies, "Convince me." Fact 55. The exoskeleton suit. Before exoskeletons, lifting impossible weight or helping paralyzed patients walk again belonged mostly to comic books and action movies with suspiciously confident background music. Then engineers decided reality deserved better special effects. Powered exoskeletons use motors, sensors, and structural support to enhance human movement, turning fragile knees into something with corporate sponsorship. They help factory workers lift heavy loads, assist rehabilitation in hospitals, and allow some patients to stand and walk with mechanical support. It feels futuristic because it is. Wearable robotics quietly rewriting what bodies can do. Exoskeletons changed medicine and industry by proving strength does not always have to come from muscles alone. They are part healthcare, part engineering, and part humanity, refusing to accept physical limits politely. Science essentially built wearable determination and gave it straps, batteries, and a deeply intimidating walking posture. Fact 56. The space station. Before space stations, visiting space was mostly a dramatic round trip where astronauts arrived, waved politely at Earth, and came back before anyone forgot to feed the dog. Then orbital stations changed everything by making space less of a visit and more of a very expensive apartment with extraordinary views. Structures like the International Space Station allow humans to live and work in orbit for months, studying physics, biology, and the emotional consequences of floating near your coworkers forever. Microgravity experiments revealed how the human body changes without constant gravity, proving bones are surprisingly dramatic when left unsupervised. Space stations advanced medicine, engineering, and international cooperation, which is impressive considering people still argue about office coffee on Earth. They proved humanity could build laboratories above the planet itself. Also, they confirmed that even in orbit, someone still has to clean up after everyone else. Fact 57. The gravitational wave detector. Before gravitational wave detectors, Einstein predicted ripples in space-time itself, and for a century the scientific community basically responded, "That sounds beautiful, but also suspiciously impossible to prove." Then LIGO arrived and listened to the universe with absurd precision. These detectors use lasers traveling through enormous vacuum tunnels to measure distortions smaller than a proton, which is like noticing someone moved your sofa by the width of a thought. In 2015, they detected gravitational waves from colliding black holes over 1 billion light-years away. Humanity had effectively heard the universe blink. It changed physics by confirming one of Einstein's greatest predictions and opened a completely new way to study the cosmos. We were no longer just looking at space, but listening to it. Science built giant laser ears and discovered that even black holes eventually make enough noise to get everyone's attention. Which invention deserves the crown of genius? Tell me your favorite physics miracle below.